Hello friends, welcome back to my channel again. I am Bijay Lohar here. Today in this session we are going to discuss about a very important topic of network configuration, and that is HSRP or Hot Standby Router Protocol. Basically we are talking about first Hop Redundancy Protocol, and I hope you guys must be familiar with the term redundancy. When two or more devices is configured in such way that if a device goes down, automatically the responsibility of first device carried by another one and start working like normal, that kind of configuration is called redundancy. So why we need redundancy for our first hop? As we know that our first hop is our local gateway. So why we need redundancy for our gateway? To understand this thing, let's have some topology here. As you can see, in our first topology we have a local router connected with an ISP server. So our LAN users are accessing internet service through this gateway and this ISP server. But what will happen if this ISP or internet link or this gateway goes down? In all the ways, our user will not be able to access the internet service. So what will be the solution? Let's proceed with the second topology. As you can see here, instead of using a single ISP server, we have two different internet link or two different ISP server. So if one ISP goes down or internet link goes down, our user will still be able to access the internet service through the another ISP server. We can configure this thing with this router. We can manually define both link with the static routing method and can define administrative distance value for both link. Just assume that you have 10 Mbps link with the first ISP server and 6 Mbps link with the second ISP server, and you want to use your 10 Mbps link as your primary internet link and 6 Mbps link as your backup internet link. So you can define the administrative distance value for both link. As we know that administrative distance is an anonymous number used to define trustworthiness of a route, and minimum the administrative distance value of a route will be the most trusted route. So by default a static route uses 1 as the AD value. So you can define little bit higher AD value for secondary route so that your router can prioritize your 10 Mbps link as your default route, because the administrative distance value is 1 and 6 Mbps link has little bit higher as the administrative distance value. So user can forward internet traffic through the first gateway or 10 Mbps link, but if that 10 Mbps link goes down, router will automatically forward the traffic through the 6 Mbps link. But still we have a problem here, that if this router goes down or gateway goes down, our user will still not be able to access the internet service. So to overcome this problem, let's proceed the third topology. As you can see here, instead of using a single internal gateway, we have two different gateway. So both gateway will connected with different ISP server, and if any ISP internet link or gateway goes down, our user can still use internet service using another gateway and another ISP server. But it is very difficult to operate because it will not be applicable in a production area. Just assume that you have 10 Mbps link with the first gateway and you want to use IP address of this interface as the gateway for all computers. But if any reason this gateway or internet link or ISP goes down, you will have to change the gateway address for all computer so that computer can send request from another gateway to another ISP server, and this is not easy to operate. So here is the situation where the first Hop Redundancy Protocol comes in, which allow us to configure our both gateway in such manner that if a router goes down, automatically the responsibility will be taken by another router and start working like normal. This will be the primary and secondary gateway. Anyone can be primary or secondary gateway at the point, and at a time one router will operate as a gateway, but if that particular router goes down, automatically the traffic will be forwarded to another router or another gateway, and without changing any gateway address. So these are the protocols which enable us for configuring our gateway as redundancy, and the first one is HSRP, that is Hot Standby Router Protocol. It's a Cisco proprietary redundancy protocol, so only Cisco router can use this protocol for the redundancy. And the second one is VRRP, that is Virtual Redundancy Router Protocol, and it's an open platform protocol, so any other vendor router can use this protocol for the redundancy. And the third one is GLBP, that is Gateway Load Balancing Protocol, and again it's a Cisco proprietary redundancy protocol. provide us the redundancy feature as well as the load balancing feature. Load balancing defines when a gateway is getting more traffic, that will be automatically set to another gateway, and both router will work together for the network convergence. But for the CCNA perspectives, we will discuss about HSRP in our practical session. So we have a network here, as you can see. So we have a LAN network with 192.168.10.0 network, and we have two different gateway, and both gateways connected with ISP server, so that if one ISP goes down, automatically the traffic will be forwarded to another gateway and another link. And just assume that you have a server other end of the internet and your user have to access that server continuously. So we'll have to configure both router in such manner that if this router goes down or this router goes down, our user will not be interrupted to access the internet service. So we are going to configure hot standby router protocol. So in this session, we will configure a virtual IP for both routers LAN interface, so that virtual IP address will be the gateway for all LAN computers. So let's configure it. It's very easy to configure. I'm accessing the command line interface of first router, and let's see what is there. As you can see here, it's a fresh router, so nothing has configured right now. So we are going to configure some basic thing. As you can see here, configure terminal. Host name of first router is P gateway, whatever name you can use here. I'll use P gateway, that is primary gateway. Okay, now I have to configure interface fast Ethernet 0x0, which is connected with the LAN computer. So as the IP address is given here, 192.168.10.1, I'll assign IP address for the fast Ethernet 0x0 is 192.168.10.1 with the subnet mask 255.255.255.0. Okay, no shutdown, done, exit. Now I have to configure the serial interface of our first gateway, and interface serial 0x0. IP address for serial interface is 192.168.100.1 with the mask 255.255.255.0. We are not discussing here about translation or something, because it's just to show you how the standby router operates. Basically, when we connect with ISP server, we have to configure the NAT configuration, but we are using a basic network here to see if our router is operating with hot standby router protocol. Okay, so we have configured our serial interface. Now we have to use command no shut. Okay, done, it's up. We do not need to execute clock rate command here, because we are at the client end. Always ISP end used to set the clock rate. Okay, done, exit. Now what else I have to do here is I'll have to define the routing method to forward the internet traffic through the ISP. So I'll use default routing method like IP route 0.0.0.0 0.0.0.0, which defines its default route. Whatever traffic comes to the router and router doesn't know about the destination address, that would be forwarded to the next hop, and that is the ISP server with the IP address 192.168.100.2, as you can see here. So all the traffic comes to this router and router doesn't know about the destination address, that will be forwarded to this IP address or this router. Done. Okay, so our first router is ready now. Let's verify the connection if our computer is accessing our server. Let's verify the IP address of server. As you can see here, the IP address of server is 172.16.0.2. So this computer must be accessing this server from this gateway. So let's verify the gateway first for this computer, and the gateway will be 1. Okay, this is the first gateway we have. So our computer must be accessing our server over the internet. Let's verify the communication. Yes, we are getting reply. So our computer is accessing our server, and now if you want to verify the route, use tracert command or trace route and 172.16.0.2 2, and you can see here our packet is moving through 192.168.10.1. It means it's the first gateway which is forwarding the traffic through the ISP server. Now this route is okay, so we'll have to configure this route. What we have to do here is, as we configured our first router, we'll have to configure this one. Configure terminal, host name will be S gateway, that is second gateway, secondary gateway. Okay, now I'll have to configure interface fast Ethernet 0x0. Make sure that your LAN interface must be in same network with other router so that they can communicate with each other. And now IP address for this interface will be 192.168.10.2 as I have given here. Okay, 255.255.255.0, no shutdown, done. And now I'll have to configure serial interface 0x0. And now what I am going to do here is I'll have to assign IP address for the interface which we have got from ISP server, and that is 192.168.200.1, 192.168.200.1 with the mask 255.255.255.0. Okay, no shutdown. Again, we do not need to execute clock rate here because we are at the client end. Done. What next we have to do here is I'll have to configure routing method as we configured in our first router. So what I am going to do here is IP route 0.0.0.0, 0.0.0.0. So any traffic comes to this router must be forwarding to 192.168.200.2, which is the next hop address of this router. So any traffic that router doesn't know about the destination address, that will be forwarded to this IP address. Okay, done. Now we'll have to verify if this link is working properly for accessing internet service. So we'll have to change the gateway for verification. Now I'll have to verify if I'm getting reply from remote server. Yes, we are getting reply, and you can see here our traffic is moving through. This is the second gateway of our network. So both gateways working properly, and now we are going to configure a virtual IP address for our LAN interface so that our computer can use that virtual IP address as gateway, and our router will operate like a primary and secondary gateway. So if primary gateway goes down, automatically the secondary gateway will state itself as the primary one and operate like normal. So what we have to do here is, it's a single command for configuring a standby router. So what I am going to do here is interface fast Ethernet 0x0. Be careful, I am accessing LAN interface of first router or gateway and using command standby. You can verify the other option we can use with standby command, and that is first will be the group number. So I'm using 1 as the group number, and it would be 0 to 4095, anything you can use that, and the IP address or virtual IP address will be 192.168.10.100 as I have given here. Okay, done. This is a single command to configure your standby router, and now I'll have to configure this router with the same command. Enable configure terminal interface fast Ethernet 0x0. Be careful that we are configuring our virtual IP address in fast Ethernet 0x0. So the standby command, and further we'll have to assign the group number, and this group must be matched with the first router, and the IP address will be 192.168.10.100. So we have enabled our router for the hot standby router protocol, and now let's verify if our router is working like standby router. First of all, let's verify the configuration of this router. So standby, as you can see here, what result we have, that this is an active router. So this one is the active router, that is P gateway, and this is the state has changed, and virtual IP address is this one, and the active MAC address, virtual MAC address is 0000 0C07 and AC01. So this is the default MAC address of HSRP virtual IP address, and this one is the group we have used in our standby command. So this one is your active router. So right now our packet must be forwarding through this one. If you want to verify this thing, let's verify it. First of all, you will have to change your gateway with the virtual IP address. Okay. Now if this computer tried to connect the server, we are getting reply, but which gateway we are using, we can use command traceCert 172.16.0.2, and as you can see here, your packet is moving through 192.168.10.1. So we have used the gateway address as 192.168.10.100, but our packet is moving through 192.168.10.1. So by default, this gateway is using for forwarding the traffic over the internet. And what else we have here? Local virtual MAC address is this one, default, and the hello time, that is of 3 seconds. So both router will keep sending hello message to each other to verify if they are working properly. But if a router goes down, another router will wait for 10 seconds, that is hold time, and even if that 10 seconds expire and another router doesn't get reply for the hello request, automatically the second router will change its state to active. Okay, so now preemption is disabled. We'll come to this point. Active router is local, so this router is the active router, and the standby router is unknown. Right now this router doesn't know about the standby router. So if I execute the same command again, you can see here the standby router is 192.168.10.2. Now the communication has happened. So now this router know that which router is the standby router at this point. Okay, priority is 100, it is by default 100. We'll come to this point again, and group name is HSRP -fast Ethernet 0x0 -1, and this one is the default name. So now we'll have to verify if our gateway is working as standby, hot standby router protocol. Now let's just disconnect this link for a while and see what happens. This router must be automatically change its state to active. So now if I verify what I see here, so standby, I'm in secondary router right now, and as you can see here, now this router is the active router or gateway, and the virtual IP address is this one, MAC address is this one, that last one is the group ID, and as you can see here, active router is local. So now this router is local, our gateway is local, a standby router is unknown because it has disconnected, and priority is still 100, and group name is HSRP as we discussed with the first router. So now without changing anything, we must access the server. Yes, we are getting reply, but if we verify the route, and you can see here our packet is moving through 192.168.10.2. so this is the second gateway we are using, that is this one. So this router is automatically changed its state to primary router. Okay, now what will happen if this link come back? Like if you have 10 Mbps link with this link and 6 Mbps with this one, your second gateway is in active situation. So what will happen if first gateway come back again, which is of 10 Mbps? Your traffic must be forwarding through this one because that is your primary link, but by default configuration this router will be your active till this goes down. So to again come back in active situation, this router must go down. So what will configure the router, both router, so that only this link will be active and this link will be prioritized if any link goes down. Like if this link goes down, this will be the active link, and if it come back, it should be automatically change its state to active. So what to do here is we'll have to see the configuration. So a standby, as you can see here, this one is a standby right now, this one is a standby, and virtual IP address is all the things are same, but we'll have to define the preemption disabled to enable, and we'll have to define the priority little higher. So if your preemption option is enabled, router will decide which gateway will be selected as the active router. The priority is the value which is by default 100, and both router is having 100 as the default priority. So higher the priority will be always the active router, but for doing that your preemption option must be enabled. So let's go for enabling your preemption option. Interface fast Ethernet 0x0 again, and I am using standby command 1 for group 1. I'll use preemption, and your preemption is enabled. You can verify it. Exit. So standby, and you can see your preemption is enabled, but still router is confused to select the primary router. So what we have to do here is we'll have to configure interface fast Ethernet 0x0 the priority for this router, so that this link will be always the active link. So what I have to do here is I'll have to use command standby for group 1, and the priority for this link will be 110. Sorry, 100 is the default, and I am changing the priority of this router as 110. So higher the priority will always be the active, and as you can see here we have got a message that HSRP the state change fast Ethernet 0x0 group 1 state standby to active. So now this router is active, as you can see here, enable. So standby, and you can see automatically this router come back to active state. If you want to verify again, just disconnect your link. This router must be active now just after expiring your hold down timer, and now so standby, you can see this one is active. But now if I reconnect the first link, this router must be the active again because it has higher priority than the second gateway. So standby, wait for some time, let's the link comes up, and further our router will change its state to active. As you can see here, we are getting a message that the state has changed. So standby, and now again it's active by default. So your this link will always be your primary link, and your user will be using internet service without interruption. So guys, this is the hot standby router protocol. We'll discuss about the further topic in our another session. I hope you guys like the video. If so, please do subscribe with our channel, and till next one, bye bye.